part two of a two-part episode. I've got Neha Pawar, who's a founding engineer at StarTree and a member of the Apache Pinot PMC, talking about why she thinks Pinot is special. We talk more today about Pinot's pluggable architecture. We talk about how upserts work, how the Kafka integration works, and of course, the famous multi-stage query engine. Listen in on today's episode. Hello and welcome to another episode of the Real-Time Analytics Podcast. I'm joined again this week by Neha Pawar. Neha is a founding engineer of StarTree and a member of the Apache Pinot Project Management Committee and a core contributor to Pinot and a friend. Neha, welcome back.
So glad to be back, Tim. Hey, everyone.
I asked you last week what makes Pinot special, which is nothing much to that question. And we got through some things, and I think we speculated that we might need another episode, maybe more, to get this done. So let's just keep going. What is another thing that makes Pinot special?
So last week we talked about indexes, and we spoke about a lot of the indexes in Apache Pinot, like inverted index, range index, StarTree index. And then we finished off by talking about sparse index, which we mentioned is available only in StarTree Cloud. And this is kind of the way we did this, or the reason it was easily possible to do something like this is because Pinot has a highly pluggable architecture. And the reason that, or rather the things that led up to this were a little bit of like history or context here. So around 3.5, 4 years ago, when the community was still small, and the adoption was pretty much only in, say, LinkedIn and Uber at that time. Because the project started in LinkedIn and Uber, and those companies were big into, say, Kafka, and then they used HDFS and some few file formats. So Pinot was very much only supporting or tied closely to these sources. And then when we realized that we want the community to grow, and then we were hearing from the community that, hey, we want to consume from these different real-time sources or from keep data in these different object stores.
Batch sources that aren't HDFS. Maybe somebody had some, yeah.
Yeah, so like S3, GCS, and then people said we want to ingest from Kinesis and Pulsar. So we decided that, hey, we want people to be able to do this without it being like a super big lift and a lot of code factorings. It should be really easy to come in and just say, plug in their connector or their plugin module is what we call it. That's where kind of we made Pinot's architecture super pluggable. We kind of have a very clean layer of, we call it the SPI layer, service provider interface.
The Java thing where you put the jar in the class path and the magic happens.
Yeah, exactly. And so you can not only now plug in your ingestion sources, like the ones that we just listed, or the storage sources, or the object stores, but we also this helped us open the gates to plugging in even core pieces like a new index or like sparse index, what we talked about, or another thing was like the segment SPI. So you might wonder, okay, what is segment SPI? So the concept of segment and it being on, say, local disk versus now you can plug in a segment that resides anywhere. So we kind of used this SPI model to also build more advanced features such as tiered storage. And there is a very mature concept of tiered storage even in open source that uses like various tenant pools, or you can use multiple volumes. But using segment SPI in StarTree Cloud, we were able to kind of put segments on object stores and then query it directly from object stores.
I want to link to the Lightboard you and I did about how that works. You went into a fairly detailed explanation that works better as video, because there's kind of some stuff you had to draw on the Lightboard. But that's anyway. Link in the show notes. Go watch Neha's Lightboard on tiered storage. It's actually really cool, and it is again you said this, Neha, but it's a StarTree Cloud feature, not an Apache Pinot feature, the thing that we're talking about right now. And super cool because the whole, if I may, for a moment, the whole kind of conceit of Pinot being fast requires tightly coupled compute and storage. You need a CPU that's going to do query computation, a PCI lane, and an SSD. That whole thing needs to be a unit for that to work. And when we violate that and put segments on the other end of a network connection, which segment SPI lets you do in a fairly in a way that doesn't require that you rebuild Pinot in some way, right? Well, that changes the game an awful lot because the latency characteristics are suddenly terrible. But there's a bunch of things that the StarTree Cloud team did, and well, you led this team in building tiered storage that made that a lot less bad than you might think. It's super cool. Go watch the Lightboard. Shameless plug for Neha's work. Neha, please go on.
Yeah, I mean, I think the video would do a much better job, but like Tim mentioned, putting it on an object store with the SPI was just part of it. We wanted to make sure that it continues to be fast so that the use cases that our users are used to serving using Pinot, the user-facing analytics, they still, I mean, of course, there is a trade-off in latency, but you don't want to have it be so slow that now all you can do is just like ad hoc queries and reporting. You still want it to be pretty fast.
Mm-hmm.
And we kind of spent a lot of effort and chased this down so that now we still get sub-second latencies even though our segments are sitting somewhere in an object store.
A cloud blob store. Yeah. And that's mind-blowing. And even from just, I don't need to spend all episode on this, but it's cool because even from the user-facing analytics perspective, just me as some person doing something, I kind of expect when I'm setting a date range and looking at some old thing, I'm just not surprised for that to be a little slower, right? Like the current stuff, everything's fast. I'm a synchronous human being. I tap something, I expect it to change. I'm also deeply impatient. Unfortunately, bad trait. So, I expect that stuff to be fast. But when you go back to older data, it's almost intuitive that it slow down a little bit. And the way you guys built that, it slows down only enough that it's kind of in that range of, oh, okay, yeah, you had to go get that from the older data. I still feel okay. You're not sending me an email telling me the CSV file is ready to download, because you hate me. So anyway, yeah, it's a cool feature. Check out the video. But pluggability generally, Pinot is pluggable, I think is what we were saying.
Yes. Yeah, you have to be careful to not let me keep talking about tiered storage.
And me too, I'm the criminal here too. It's just a cool topic. I'm just constantly impressed by how you guys did that and the numbers you were able to clock. So it's fun stuff. And it relies on Apache Pinot being fundamentally pluggable, not just in its indexes, but in how segments are implemented. Are there any other major points of pluggability? I only ever think of segments and indexes.
There are several more. And one that comes to mind is what we did in upserts. And to talk about that, maybe we can dive a little bit into the upserts feature in Pinot.
Let's do it.
Cool. So if you're not familiar with what upserts is, so this is, I think, a line I heard. I don't know if it was in one of your decks, Tim, but data in motion tends to stay in motion. So when you have events coming in or like data for things like financial dashboards, or for example, if you think of Uber and they have these financial dashboards where they're trying to do accurate reporting of a ride fare, where you could have later added some toll, later added some tip, or you're trying to say get the most accurate order status where that order status kept updating. So, or anytime you're trying to do analytics on data that you are connecting from some OLTP system where that the event, it's going to keep changing because it's a transactional database. So the ability to handle this, like update if it already exists or insert if it does not, is what we call upserts. And historically, real-time OLAP systems, they were not designed to handle upserts. And there's an architectural reason for this is because they were designed as append-only systems. They had immutable data structures, because of which it was really easy to scale. You had better performance. The system complexity was lesser.
Better life.
Recovering.
Immutable data. Everything's better. And I mean, you hinted at this, but the assumption is an analytics data store is ingesting things that have happened, right? And so they're events, they're written into the log of the world, and they don't need to change. And so you get to treat them as immutable, and life is sweeter as a result. But in a real-time analytics database, like you said, there are entities that you're ingesting, and entities mutate. So the ride, the order, the whatever it is you're ingesting from the CDC, from the OLTP database, it isn't just events anymore. If you're really going to be a proper real-time analytics database, you do need to ingest streams of mutating entities. And so keep going. Upserts.
Yeah. Very, very well said, Tim. Thanks.
The data in motion tends to stay in motion was not my line. I like that though.
So now with this background, when we built upserts in Pinot, the kind of principle that we wanted to hold on to was that we want to still do low latency. So we need to minimize the impact on scalability, on performance, and also it should not be super complex to ingest and query the data. So why I talk about complexity of ingestion and query is because there's several systems that kind of have the concept of upserts, but what they would just do behind the scenes is use some async process or some background processes to kind of update the data. And that's obviously going to result in inconsistencies, plus going to be operationally expensive.
Mm-hmm.
Or they might just rely on batch ingestion. Or even worse, you might be expected to write some complex UDF to kind of construct your query and decide for yourself how you want to kind of pick your latest event by doing some complicated query logic.
Yeah, that doesn't seem like a net increase to human flourishing. I think we could just put it politely. So
in Pinot, we have upserts supported very natively. And the way we do this is let's say you have a partition stream, and then we're going to keep a map of every partition or primary key. So we have this concept of every event you have to have a primary key. That's the key that we will use to decide the upsert or update or insert.
Seems fair, right?
Yeah. And then we're going to have a map that we keep from key to kind of the latest location of the record for that key.
Okay.
And then we're also going to have a per segment bitmap, so to say, to indicate what are the valid document IDs. So a combination of these things will let you, these things that are being built during the ingestion, combination of these will let you query really fast because you have the bitmaps that you can kind of look up really fast. And then you have the map that's telling you in the latest consuming segment what is the latest record that you need to look at. And then this kind of helps you do your ingestion and query with very little overhead because it's just one additional map in memory to look at. The querying the bitmaps is really fast. And at the same time, because we're not actually mutating the data, we're just doing this metadata magic, it opens up use cases, or if you wanted to do what you call time travel, where you have updated, but you still want to then go back and look at the history of, hey, what really happened that caused, like what were the events that led to this update? You still have the option to do that.
Okay. And there's a function in the query, I assume, that syntactically lets you do that time travel you specify in the query.
Yes. So it's just like a query option where you can say skip upserts, then you'll get everything.
Oh, okay. You get the whole list. Got it. Okay.
Yeah.
So, you can occasionally tell when I'm asking a question for the sake of clarifying to the audience, and then when I'm asking a question that I legit didn't know. Sometimes I'm just going to call myself out. I feel like I should have known that. Didn't know that, so that's good. Yeah, I'm learning. Thank you, Neha. And that map then is, it's an in-memory data structure. It is effectively a hash table where the key is the primary key, and what you get out of it is that here's the current thing in the current segment. The actual doc ID that represents the value that we are going to use now. So we just have this. In other words, segments get to stay segments. Data is still immutable, right? We don't change any of that. We just have this thing in front of it that lets you pick which of those values we've written we want to be the official one.
Mm-hmm. Okay. Yeah, and speaking of that map, and going back to the pluggability question that you had. Mm-hmm. So now, of course, it's an in-memory data structure beyond a point when you hit a certain scale, and users of Pinot usually do. Mm-hmm. You're going to have, if you have like a whole lot of primary keys, like think of like hundreds of millions or billions of primary keys per partition or per server, then that the memory footprint of that map is going to get more than you can handle at some point.
It is at this point that the Go and Rust and even C++ folks are pointing at us and yelling and saying, "I told you so, you and your heap." Right. But yeah, that's an on-heap thing in the JVM. And right. It clearly has the opportunity, there's going to be heap pressure at some point, right? Things are going to get big, and we don't like that.
Yeah. Yeah. But this is where in StarTree Cloud, we added a plugin for this metadata map, and we pushed it to using off-heap memory. Oh, so now it's a lot more efficient, a lot more predictable, and you can free up all your heap space for doing other query goodness.
Cool. And, at some point, that being in StarTree Cloud is, heap is our problem, right? We're the one managing it. But depending on the kind of cluster you have and the way, you still have a certain amount of visibility into servers and brokers and things like that. So it is very valuable. And that's a good thing to be able to do. So nice little StarTree Cloud, a little bit of pluggability, getting metadata, upsert metadata off heap.
And while we're still talking,
we're talking about upserting. Can I ask about deleting?
Yes.
All right.
Yeah. So in upserts, like we talked about update or insert, but it's not just limited to that. We also are able to do deletes. And that's, of course, very important because typically if you are, like we were talking earlier, connecting to some OLTP data source using some change data capture system, then you are bound to also end up with an event that was just like deleted. So in Pinot, we are able to handle those with we do like a soft delete. So it's still there. So you can still do the time travel, but from the query perspective, you can consider it deleted. And similar to that, we can do partial upserts because again, if you have data coming in from like OLTP sources, you're going to have something that changed a little bit and then something else from that entity changed later, and you want to be able to stitch that together and provide kind of the latest view, whether it was like a partial update or a delete. So we have all these functionalities available.
Okay, it all gets very subtle. I will have a link in the show notes. A few months ago, Navina Ramesh was on with a deeper dive into upserts and deletes. I think that was around the time she was working on delete itself. So I'll link in the show notes for that if you want to go back to that episode and get more on that. But that is the thing that makes Pinot special, because to do that, and I mean, we're not here to talk about why other real-time databases or real-time analytics databases are bad. So I just want to be careful in the way I say this, but to get that done without a mechanism like this, you do end up having to just kind of juggle a lot of balls and do a lot of gymnastics, because the whole theory of being an analytics database, again, is that things don't change. And I think the community is discovering, but they do. Now that we're doing real time, we do need to worry about evolving entities and do analytics over those evolving entities. And so this is just a key part of the Pinot is special story.
Yeah.
I'm asking you the why it's special question. I have another thing I want to ask about. Can I?
Yeah.
Can I do that? All right. I call it, Kafka aware ingestion, Kafka partition aware ingestion. I know there's a slightly more general name for that, but it is actually in your and my history of people who know each other. The first really exposure I had to Pinot was some talks I did jointly with you early in 2021. It's the end of September 2023 as Neha and I are recording this. This will probably air in October or November, so very soon. But early 2021, company wasn't even called StarTree. It was in stealth. I'd never heard of Pinot, but we did these joint talks where we talked about, because I was working for Confluent and doing work on Kafka at the time, about how the Kafka Pinot integration worked. So I think that would be a great topic to end today's discussion with.
Yeah. Yeah. So Kafka aware ingestion, I think what we more generically call it is low level consumers, or you can call it like a native pull based ingestion. And why I say low level or native pull based is because there's another way to ingest from streams, and that's, or particularly from Kafka, and that's using like consumer groups. Versus now, like Pinot started off using consumer groups, and then very quickly we moved away from it. There's some other systems that still use consumer groups, but in general, with consumer groups, you kind of don't have control on a partition level.
You don't know what partition you're going to get assigned a partition.
Yes,
there's a dance between the consumers in the group and the cluster to divvy up partitions,
right.
and they change, but you don't want them. Yeah. Anyway.
Right. So yeah, like you said, it can change. So you don't have control of what offsets you're consuming from, or it's much harder to, like, you sometimes have to manage, or rather you don't get to manage your own offsets and checkpointing. So you're kind of at the mercy of what is coming to you. So if there's like nodes going down and reassignment happens, and you just have no handle on what events are going where, and much harder to guarantee kind of a consistent and accurate view of your data. So what we did was to do low level consumption, or partition aware consumption. So we are able to just connect exactly, like we have control of, hey, here's the partitions, here's how we'll distribute it amongst our servers, these are the offsets that we'll consume from. We'll kind of record all that metadata on our side. So if there's like node failures or kind of switchovers to other nodes, capacity changes, we have full control of, hey, this is how much we've consumed. The new node needs to start consuming from this point. We know exactly what all our replicas need to be holding in terms of start offset to end offset from which partition. So it's just a much easier operationally and accuracy wise way of operating things with Kafka or any other partition stream for that matter. And then, like we touched upon in some other portions of our discussion, we're able to use this partition info in various parts of Pinot, like smarter data placement, smarter queries and pruning, and so on.
Yeah. Why does it matter? So, and actually, let me back up. Let's just talk about Kafka for a second. The basic model over there, I think many listeners know this, but if you don't, I don't want you to be lost. Messages are put into logs that we call topics. A message is a key and a value, and a topic can be split up into multiple partitions. Each partition you can think of it as a single file that lives on a broker somewhere, right? So that partition is this strictly ordered collection of messages. And it's often the case that messages are assigned to partitions based on their key. So it's a key value pair. That key is something in the domain of the data that you want to determine ordering. And since messages are assigned to partition based on key, you have a guarantee of strict ordering for a given key. So Pinot, you just said, does this thing where when it's consuming, and the consuming happens at the server level, right? So the server is being a consumer. It's not being a consumer group with partitions coming and going and somebody else being in control, but it says, all right, this is the topic. There are 5 partitions. I am taking 0 and 1. And as a server, I am consuming those 2 partitions. Don't at me. Those can't change. Meaning all of the keys that are in 0 and 1 are always going to be coming into me. So why does that matter? If that makes, or if you want to back up and explain other things, but I just wanted to, frame the whole Kafka partitioning thing. And I think the net effect of how you described the native ingest working is that a server is guaranteed always to be consuming from a certain partition or set of partitions.
Mm-hmm.
And then that helps you do what in pruning and why are queries faster? What kind of queries are faster as a result of that?
Right. So now that, let's say you had a partition based on a column like company ID. And now if you knew that for any company ID value, if you apply some partitioning function like murmur3, and then whatever value you get, let's say you have 10 values that you're producing. And if you know that 0 and 1 are always on a particular set of servers. So anytime you query for a company ID and you kind of hash to that value, you just have to go to servers that are responsible for 0 and 1. And that helps with pruning out the number of servers like we talked about, or sometimes even within a server, pruning out the number of segments. In general, just tying back to our philosophy in Pinot of do as little work as needed, because we want to do smart work and not just try to scan everything. And I mean, of course, you're going to get the correct result in both approaches, but we want to do it optimally so that we can be fast.
One of them's going to take longer, yeah. And the when that partition key shows up as a predicate, it's incredibly valuable to know what segments are going to have that key.
Yeah.
On that basis, we've talked about across 2 episodes, if I can remember. We talked about indexing, talked about the basic framing of Pinot as a real-time analytics database, pluggability, upserts, native pull-based ingestion, some StarTree cloud features. Anything else? We're kind of at time, but what did we miss anything?
Yeah, so one of the things that are kind of one of the most recent developments that's happening in Pinot is the multi-stage query engine. So we kind of had like a preview of it released maybe a year ago, where it was working for some use cases and for some algorithms, but now we kind of have it functionally complete. And why that is important is a little backtracking. When we talked earlier about the brokers and servers, and we said how brokers scatter stuff to servers send results back, brokers merge the results. This is pretty much like a single stage scatter gather. And now if you're doing more complicated queries, like that works great for like your typical OLAP analytical style queries, like your filters, group bys, and order bys and aggregations. But if you have something more complex, like window functions or joins, then the single stage can pretty much become the bottleneck, because you're going to have to do more and more work later and not just at the leaf servers where you're doing the first level of computation. With the multi-stage query engine, we now have full support for natively doing joins in Pinot. And this is exciting because if you think of the joins spectrum, there is kind of multiple ways for you to ingest and query data. So you could either be just pre-cubing everything. We talked a little bit about it in the StarTree discussion. This is what things like key value stores do. Or you could be doing everything on the fly. So you could just have keep like your data in like raw star schema and have to like join everything during query time. Or there's stuff in the middle where you pre-aggregate a little bit, like materialized views, start indexes, or you have to invest efforts in doing like a denormalization, so pre-join. So that's kind of the spectrum we talk about: pre-queue, pre-aggregate, pre-join, star schema. And without native join support, Pinot Pinot was able to do the, if you pre-cubed everything, yes, Pinot can handle it. Do some pre-aggregations, Pinot can handle it. Pre-join, of course, Pinot can handle it. But if you had just left your data in star schema, we would have to rely on some query federation layers to be able to execute those queries. But with native join support, you don't have to rely on those layers to do joins within the scope of Pinot. And what's exciting, like why I say functionally complete now, is because we support all join types. We are able to execute joins in algorithms like broadcast join, if that makes sense, or if it makes more sense to do a shuffle hash distributed join where you're just sending all data from left and right to like another intermediate stage, we have support to do that. So just it's whole bunch of ways you can lay out your data or execute the join algorithm or just the join types. Pinot can now support all of it very well.
Yes, and that is recent as of this recording. It was just about a week and a half ago that was a 1.0 so-called functionally complete feature. So, and we'll link. We got a blog post about those join types that I think you wrote. So
yes,
we'll link to that if you want more on those join types. If you don't know those different approaches to joining that Neha just listed off, she will explain them to you in writing. So we'll link to that in the show notes.
Yeah, and in that blog we also talk about a lot of the reasons why we think our joins are going to execute really efficiently. We'll talk about some of the optimizations, like the dynamic filtering that we can do, or how we're able to make use of all the optimizations we talked about in Pinot. We can still make use of them in the multi-stage engine, like pushing down predicates, pushing down group bys, pruning, and just we also shared some performance numbers. So definitely go take a look at that blog.
We've covered a lot. Thank you for adding multi-stage query engine. That's a key thing. We'll probably talk about that more on the podcast in the future. We've got some video resources coming on that. There are some things that are important to visualize. It's important to understand, and this is a great preview. And thank you. My guest today has been Neha Pawar. Neha, thanks for being a part of the Real Time Analytics podcast.
This was so much fun. Thank you, Tim.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.